Welcome to another Makersafer video, making the world a safer place. This video is about laser cutter and laser engraver safety. Okay, let's meet the team. Gambo Valdez, electrical engineer. Scott Bauer, mechanical engineer. Tyler Bickel, civil engineer. And Sam Pizarro, electrical engineer. Okay, let's get started. Laser cutters and laser engravers are incredible pieces of equipment. Here you can see us taking the logo and turning it into a design to be utilized on a laser cutter. After the files have been completed, we can activate the laser cutter, the air filtration systems, and the air supply. After all the safety checks have been completed, we can then load our materials onto the laser cutter bed and close the lid. Here are two short clips of a laser cutter in action. Okay, now it's time to talk safety.
So let us start by asking the following. Would you like to go blind, suffer devastating lung damage, start a fire on your laser cutter, burn down your home or office? How about possibly inhaling hydrogen chloride, which could lead to death? If the answer is no, then you are in the right place. We're a team Makersafer. We're here to help you develop your understanding of the basic safety protocols needed to get you started on the path to using laser cutters safely. For most of you, this is likely to be your first experience using a laser cutter. We want to inform you that there are real hazards to take seriously when working with laser cutters. Take note, our video cannot possibly be 100% comprehensive. There may be other safety risks present when working with laser cutters based on the type of material and equipment that you are working with. We cannot anticipate every possibility or combination you may come across. This video is intended to be the starting point in developing your knowledge of laser cutter safety. We started out listing a few of the possible risks associated with using a laser cutter. You should do your own research to mitigate the possible risks not covered in our videos. If you're still unsure, ask a supervisor or even consult with the manufacturer with any questions that you may have related to the safe operation of the equipment. First step. We want you to commit to memory the general rule of thumb to keep any jewelry, loose clothing, or long hair clear from any mechanical equipment you are working near. These items can become entangled or get caught in the machinery, resulting in an unwanted injury. Okay, let us get specific to laser cutting and etching.
Laser light is also known as laser radiation, can be extremely dangerous if not taken seriously. Capable of instantly damaging your eyes, causing partial or even total permanent blindness. The laser radiation emitted by the laser cutters is strong enough to cut through paper, plastics, woods, or even metals. These lasers, if not safely operated, are definitely strong enough to permanently blind you or someone else within the proximity to the laser. Levels of laser radiation strong enough to cut these materials are definitely strong enough to burn or even cut through you or a bystander. Laser cutters will use mirrors, lenses, and fiber optic cables to direct and focus the light down to the cutting surface. The stray laser radiation may easily be as dangerous as the directed laser itself. Many laser cutters have enclosures that will help block and filter out specific frequencies of laser light used within them. There are many consumer versions of laser cutters that are not contained within an enclosure. For those laser devices, the appropriate laser-approved eye protection must be used in accordance with the frequency of light produced by the laser. Those types of laser devices are outside the scope of this video, owing to the extreme hazards associated with them. We just want to inform you there are many additional safety measures that must be taken with those devices. We recommend you do not operate open-air laser cutters. Please be extremely cautious when you are around any kind of unprotected laser device. Extra caution must be taken when working with highly reflective or even partially reflective materials, as they pose a significant risk of broadcasting concentrated laser radiation in unintended directions. So, extra care and safety must be used when working with any type of potentially reflective material. That's great.
Oh, my eyes! Oh.
Whoopsie! Laser cutters most often use wavelengths of light that are invisible to the human eye, and therefore there is no chance of you being able to see potential errant laser radiation before significant injury has occurred. Reflective, stray laser radiation is easily as harmful as well. If you do see the laser beam in your eye, at this point it's already too late. Permanent damage can already have taken place. It must be said, never look directly into a laser emitter and always wear proper eye protection. We can't stress enough the importance of using proper ANSI laser-approved eye protection by you and all of those around you who could be exposed to potential laser radiation. Proper ANSI-rated eye protection must be worn to prevent permanent eye injury or even blindness. Even the most minor exposure to stray laser radiation can injure the eyes. This can be like an intense sunburn to the eyes and can be very painful for an extended period of time, even days. ANSI Z136 OD specs safety glasses will be labeled clearly with information along the lines of OD5, OD6, or OD7+. These ratings are specifically based upon the wavelength of the laser you're working with. ANSI-rated eye protection will be clearly labeled on the goggles. Don't use cheap generic safety glasses or sunglasses. These will not protect your eyes from laser radiation.
This leads us into electrical shock hazards. We have found that diode lasers can output 100 watts. High-powered CO2 laser tubes can produce outputs up to 40 kilowatts, and fiber lasers can output up to 100 kilowatts of power. These are some serious levels of power output for these kinds of lasers. To create this kind of output, you need real serious electrical input. The levels of voltages running around inside of laser cutting equipment is no joke. You should never operate laser cutting equipment that is not properly grounded, nor should you ever open the paneling containing the inner workings of this equipment, unless you have been specifically trained to work on the laser cutting equipment. The risk of electrocution is very real, even if the equipment has been unplugged. Jewelry, loose clothing, and long hair can become great conductors of voltage straight into your body. Electrical shock can lead to instant death. As for now, there is no known cure for death. Avoiding electrical shock is the wisest course of action in our opinion. So be mindful of your jewelry, clothing, and hair when working with laser cutters. A laser cutter should never be plugged in or operated if a lockout tagout placard or lockout device has been attached to the machine, as hazardous electrical faults could be present. Fire hazards. Let's talk about the risk of fire. The energy within these lasers required to cut through these materials is very significant. Errors in properly setting up or programming the lasers can lead to serious fire risk. Some of these errors include incorrect focusing of the laser, selecting the wrong travel speed of the laser's path, the wrong laser intensity setting for the material is used, incorrect thickness measurements of the materials, and more. Leaving a laser cutter unattended must never happen. Not having any means by which to put out a fire, such as a properly rated fire extinguisher or other equipment by which to extinguish a fire, can be catastrophic. Even if all the settings are perfect, an error within a program having the laser cut or pass over the same line multiple times can start a fire. Proper supervision of a laser cutter must be maintained at all times. If for some reason you need to leave the laser cutter unattended, you must pause the cutting job and resume it after you have returned. I repeat, under no circumstances ever leave a laser cutter unattended while in operation. Having proper fire extinguishing materials nearby is a must to prevent burning down the laser cutter or worse, the facility the cutter is located. It's important to understand that there are different types of laser cutters. For example, there are CO2 lasers, YAG lasers, and diode lasers, amongst others. Typical diode lasers are not able to cut acrylic material, while CO2 lasers can cut acrylic. Making sure that you have chosen proper material for the type of laser cutter you are working with is an important step in preventing fire. The settings for a piece of wood you're using from one cut job to the next cut job can be a significant risk of fire if the settings of the laser are not changed accordingly. A setting that may work on one type and thickness of wood can become the perfect settings to ignite a different piece of wood. This applies to plastics and other types of materials as well. So be sure to check your laser settings to ensure they are appropriate for your material selection on each cutting or etching job that you do. To be fire safe, be sure to know your emergency procedures for fire safety around any laser cutters you're going to be working with before any work begins. Know where fire extinguishers are located. Know where the fire alarm handles are located. Know your evacuation routes and meeting places in case of a fire.
Our next safety topic is about filtration and ventilation. Filtration and ventilation must be functioning properly and must be used for every job. The toxic fumes of the laser cutting and the engraving processes can cause serious injury, even death. As a reminder, there is no known cure for death. We want you to recall that laser cutters should never have any safety mechanisms bypassed. Never operate any laser cutter with either the cabinet side panels or the cover in the open position. Never operate any laser cutter without first activating proper filtration and ventilation systems. Laser cutters use the power of the focused laser radiation to etch or cut away the material line by line throughout the job. This material is burnt and eroded away, which causes the creation of smoke and the off-gassing of potentially dangerous volatile organic compounds and chemicals. It is very important to know what the risks and the hazards are for the specific materials you may be working with. You are responsible to ensure that the ventilation and filtration equipment is operating to avoid serious physical injury to both you and the others from the smoke and the gases that are being produced. It is best practice to allow the filtration and ventilation system to continue to operate for approximately 1 minute after the laser operation has finished before you open the lid to remove your work. Check the manufacturer's recommendations to be sure more time is not needed for the equipment you are working with. This will properly ventilate the cabinet before you open the lid and remove your workpieces. This leads us to the individual smoke and gas hazards. We don't want to scare you. However, proper filtration and ventilation is a very critical aspect of the laser cutting and laser etching process. As it happens, most if not all materials will produce some degree of smoke or airborne particulate matter while they're being cut or etched. The particulate matter or smoke can be as mild and as simple irritant or up to downright harmful or even possibly fatal. A variety of materials, when cut or etched, can decompose into a large variety of noxious chemicals in gaseous form. Many of these chemicals can cause irritation or severe injury for you and those around you. Natural wood-based products will cause wood smoke to be formed. Some wood smokes can contain creosote, which is an irritant and a carcinogen. Creosote can, over time, damage the laser cutter if not properly vented. There are some natural woods that, when burned, release noxious gases that contain toxic alkaloids called taxenes and other toxic volatile organic compounds. Be certain to know what species of wood you are using and check to see if it is safe to use in a laser cutter. Breathing these toxic volatile organic compounds or gases can cause permanent respiratory injuries, cancer, or even death. And let me remind you once again, there is no cure for death. Natural materials like paper, thin compressed cardboard, mat board, corrugated cardboard, and most woods that are untreated are generally safe to be cut or engraved, but will produce the wood smoke, like that of a fireplace or a campfire. Just a reminder to make certain the wood that you're working with is not of the type that will produce toxic gases. Some natural woods can be more or less sensitive or susceptible to combustion. With improper laser settings, this can be a problem. Use caution when working with a new material that you've not cut or engraved with a laser before. Corrugated cardboard can be a little challenging for laser cutting. Improper laser focusing or intensity can present a fire risk where the laser is set up incorrectly. Manufactured wood products, including the common plywood, MDF, HDF, OSB, and others, contain wood and resins used to bind the layers or particles together. When burned by the laser, these will release wood smoke and a variety of volatile organic compounds and chemicals in gaseous form. Some manufactured wood resins can contain urea formaldehyde or phenylformaldehyde. You do not want to burn resins that contain UF or PF, as the gases are very toxic. There are special plywoods, however, that are made specifically for laser cutting. They are formulated to be safer for you to use. Best practices dictate that you select laser cutter approved manufactured wood materials or stick to natural wood-based materials. As an example of a dangerous material that should never be used, that is PVC, polyvinyl chloride. It is important that you never burn or laser cut any material that contains PVC. I was taught a long time ago about these hazards. As I recall, the primary hazardous gas to be concerned about with the burning of PVC is hydrogen chloride, HCl. Hydrogen chloride forms hydrochloric acid upon contact with moisture. If this moisture happens to be inside your lungs, this will cause the formation of hydrochloric acid inside your lungs. That is beyond bad. This will severely harm your lungs and your respiratory function. Other harmful gases can include carbon monoxide, hydrogen cyanide, sulfur dioxide, and nitrogen oxide. If my memory serves me, there are a few other additional chemicals that are produced from the combustion of PVC that can pose significant risks as well. The level of exposure to these chemicals capable of causing death is much lower than one would expect. We implore you, please never take the risk of laser cutting or etching anything containing PVC. Once again, dangerous smoke and gas hazards are present. It is imperative that the laser cutter must never be operated when the lid is open or not properly sealed. If proper filtration and ventilation equipment is not present or malfunctioning, do not operate the laser equipment. Let's cover some other common materials that you may want to use. Natural fabrics like cotton, silk, linen, denim, they're safe to be used in laser cutters. Man-made synthetic fabrics are numerous and generally are safe to use as well. Just know that synthetic fabrics are hydrocarbon-based polymers that are woven into a fabric. Some fabrics are woven blends of natural and synthetic materials. Just double check the safety of the synthetic fabrics you'll be cutting before you begin. Leather products are very popular to use in laser cutters and also for laser engraving. There are various methods used in the leather tanning process. These are like vegetable tanning, brain tanning, oil tanning, chrome tanning. Many makers have worked with vegetable tanned and brain tanned leather for many, many years and have reported they are safe to use on a laser cutter. Recall for a moment, leather is made from animal hides. The most common complaint is the bad lingering odor produced while working with vegetable tanned and brain tanned leathers. A quick side note about oil tan leather. Oil tanning, to my understanding, is a secondary treatment that is done to soften the leather, and it's already been tanned using a vegetable tanning or a brain tanning or chrome tanning method. Oil tanning is just an oil-based treatment used to soften the leather. Just make sure what the primary tanning method was before you use leather labeled as oil tanned in the laser cutter. Chrome tanning uses chromium salts in the tanning process. This is a very common commercial tanning method owing to how fast the tanning process is. Chrome tanning provides a soft and supple leather, and it's really popular for most commercially produced leather products. The most common suppliers of chrome tanned leather will use chromium-3, also known as trivalent chromium. Trivalent chromium is stable, it's insoluble in water, it has a low toxicity level, and it occurs naturally in various minerals. However, chromium has an insidious and dangerous cousin called hexavalent chromium. This is a dangerous carcinogen. Hexavalent chromium was used in chrome tanning, but has since been banned in some countries. So using old chrome tan leather or leather that's been chrome tanned from an unknown source could pose a real risk. I've heard from some makers that there's a possibility that when trivalent chromium is exposed to the high heat of your laser cutter, it could undergo oxidation and potentially be converted into hexavalent chromium. Until we're able to do our own laboratory testing to determine the safety here, we are currently recommending against the use of chrome tan leathers owing to this alleged risk associated with the formation of hexavalent chromium. Artificial leathers and synthetic leathers are a hard, never use them in a laser cutter. This category contains the common modern PU leather and the PVC-based synthetic leathers, as well as like leatherette. Again, these are in the category of absolutely never use these materials in a laser cutter or an engraver. PU is also known as a polyurethane leather. When under the intense heat of a laser, this combusts and degasses, producing carbon monoxide and hydrogen cyanide gas that is highly toxic. Never use PU leather in a laser cutter or engraver. As we mentioned independently earlier in this video, PVC-based products produce many dangerous compounds as well. Please be careful to never allow synthetic leathers of any kind to become part of your laser cutting and etching experience. Be sure to check what type of leather you're going to be working with to mitigate these risks. If you can't properly identify what type of leather you have, ask an expert from a leather shop that sells leather to crafters and makers. Also, there's a product called bonded leather. We place bonded leather in the category of never to be used in a laser cutter or engraver because the glues that are used to bond the individual pieces or layers of this leather together are often polyurethane-based glues. These glues pose the same risk as polyurethane leathers or PU leathers.
Plastics are a very big category of materials people want to use in laser cutters. This category includes foams and rubbers. To name a few, we have PLA, PETG, ABS, polypropylene, PMMA, also known as acrylic, PET, and neoprene. There are many other types of plastics common to the marketplace. You will need to check carefully if the type of plastic you intend to use is going to be safe. Using any given plastic in a 3D printer is a very different set of conditions than a laser cutter or a laser engraver. Plastics like PLA, PETG, and PMMA are generally safe to use on laser cutters. PVC, ABS, PC, and neoprene are not safe to use in laser cutters. Acrylic, also known as plexiglass, is suitable for laser cutting and it cuts and etches very well with the CO2 laser. It cannot be cut with the diode laser because of the wavelength of light needed to cut acrylic. Be fair warned, the acrid smoke that is produced by acrylic in a laser cutter or engraver is really foul smelling. Polycarbonate is an amazing plastic because of its strength. Polycarbonate should never be cut on a laser cutter as it produces toxic gases and the soot produced will damage your laser cutter. ABS and PVC are very common injection molded plastics. ABS and PVC should never be cut or engraved on a laser cutter as they produce toxic gases. Plastics in general are hit or miss for safety on a laser cutter. Unless you specifically know the chemistry of the plastic and if it is safe to use in laser cutting, don't take that risk. Do your research first before you attempt to cut or engrave plastics. Fiberglass and carbon fiber. These materials are not suitable for laser cutting. These materials are a combination of either glass fibers or carbon fibers bonded together with resins. The glass and carbon fibers will not cut in a laser cutter, and the resins are likely to produce toxic gases and smoke. Glass objects can be laser etched with very nice results if the equipment is designed for it. However, the etching process will produce extremely small jagged shards of glass in a powder form. This is difficult to clean up and is not good for the longevity of your equipment if not designed for this operation. Proper personal protective equipment, or PPE, must be worn to mitigate the risk to clean up the glass waste byproduct. Follow the manufacturer instructions for the equipment when it comes to glass etching. Metals. Bare metal etching can be challenging and may require specialized equipment or chemical treatments. However, painted, powder-coated, or even anodized metals can be etched beautifully with a laser etcher of sufficient power and design. Some precautions may need to be taken based on the chemical composition of the finish applied to the surface of the metals. Metals can be very reflective, so exercise additional caution for you and those around you. In conclusion, while this video is not inclusive of every possible risk, it is our goal to introduce you to the knowledge of some of the potential hazards that may arise with using laser cutters. It is important that you take the time to understand the equipment and the materials that you are working with for every job you do. Never shortcut any of the safety procedures when working with laser equipment. They are there to keep you safe. Never leave the laser cutter or engraver unattended while in operation. You want your time using a laser cutter to be both a safe and a pleasant experience. Thank you for taking the time to watch our Makersafer video on laser cutting safety. We hope that we haven't scared you away, but rather have imparted you with some education and started you on the pathway to be a well-informed and a safer maker. Thank you for watching and happy making.